Hi there, my name is Bruce Rain from Breakers Creations, and in this video I'll be performing the Mystic upgrade on this Macintosh Color Classic. If you've never heard of the Mystic upgrade, it's where the original Color Classic logic board is replaced with the logic board from a Macintosh LC575. The upgrade got its name from the code name for the Macintosh Color Classic 3. This computer was never released, but it was going to be a 68040 version of the Color Classic. The original Color Classic has a Motorola 16 MHz 68030 CPU and has a 10 MB RAM limit. It's always received criticism for being underpowered, and when the later Color Classic 2 was released, they bumped it up to 33 MHz, but still using the 68030 CPU. So by replacing the old logic board with that of an LC575, not only do we get a boost to 33 MHz, we also graduate to the Motorola 68040 CPU. And even though the LC575 was only ever designed for a maximum of 36 MB of RAM, if you can find the right sort of memory modules, you can even upgrade it to 132 MB. That's quite an improvement over the 10 MB limit of the Color Classic. This is the Color Classic logic board. And this is the logic board from an LC575. As you can see, they're both the same size and they use the same connector at the bottom of the board. So all we need to do is to take out the Color Classic logic board and replace it with the LC575, correct? If only it were that easy. Unfortunately, the Color Classic has a 512 by 384 pixel display, and the LC575 has a 640 by 480 pixel display. And without some modifications, the Color Classic display won't work with the LC575 logic board. Now there are three options available to us to make it work. The first is a software solution where you can modify the operating system to work correctly with the Color Classic's smaller screen. The other is a hardware solution where you make modifications to the LC575 logic board so that it will work at 512 by 384 pixels without the need for a software modification. The third solution modifies the Color Classic analog board so that it becomes capable of displaying a 640 by 480 pixel image. If you've seen any of my videos, you'll know that I prefer hardware modifications, and I'm opting to go with the analog board modification so that I can get 640 by 480 pixels on the screen. This will also allow me to play some of my favourite games that wouldn't work on the 512 by 384 display of the Color Classic. Once again, there are a few options for this particular modification, but I'm going with the one deemed safest. One of the mods involves increasing the horizontal deflection voltage from 68.4 volts to 84 volts. The advantage of this mod is that you'll be able to swap between the LC575 and Color Classic logic boards at will. The disadvantage is that it increases the load on the poor little power supply of the Color Classic. I'm opting for the safer VGA mod, which doesn't change the voltage and therefore doesn't increase the stress on the power supply. The drawback of this method is that once it's done, your computer will no longer work with the Color Classic logic board installed, only the LC575 logic board. So just to reiterate, if you follow this procedure, your Color Classic case won't work with your Color Classic logic board anymore, only the LC575 logic board. But even though we'll be making hardware modifications, as long as you don't break anything, they are all reversible, so you can return your Classic back to its factory spec at a later date if you choose to. So the first thing you need to do is remove the analog board of the Color Classic. I'm not going to demonstrate this process here, but I have a separate video in my channel with step-by-step instructions on how it's done. Before we go any further, a quick disclaimer. This process can be potentially dangerous, so you do this at your own risk. I can't accept any responsibility if you damage your Mac or yourself. So let's head over to my workshop and get started. Okay, so this is the Macintosh Color Classic analog board. We're going to be having a look at this under the microscope in a moment, and we're going to be focusing specifically on this section here. Right, so you'll see here that I have marked out some lines around this pin, and they're the lines that I am going to cut in order to isolate this pin from this plane of copper. So we don't want this pin to be joined to this pin here. So I'm going to grab a Dremel and I'm going to cut along these lines to break that copper. Now I know that you're saying, you said earlier that this was going to be reversible, and it is. At the end of the day, I am cutting this copper, but if you decide you want to change it back with a little jumper wire, you'll be able to join it back up again. Now I've only got quite a large cutting tool on my Dremel. Unfortunately, if you have a look here, you can see it's pretty big in comparison to what I'm cutting. And so I'm going to have to be super careful to make sure I don't do too much damage. But I would recommend that if you're going to do this, to probably do this with a smaller cutting tool on your Dremel. So here's the horrible Dremel noise, and let's begin. Okay, so perhaps not the cleanest of jobs, but we did indeed get the job done. We have now got that pin isolated from the rest of that copper there. Might just neaten it up a little bit. Okay. Okay, now in the interest of making sure that we don't end up with any accidental shorts, I'm going to actually get some UV solder mask and paint over these bits of exposed copper that I have created here. So that when I do put my jumper wire in place, I don't accidentally end up with a little bit of that wire touching some of this exposed copper and creating an unintentional short. So just doing that now, just painting some of this UV solder mask on fairly liberally, but not too thick. If you paint it on too thick, it takes too long to dry. So just gonna do that, just make it look a little bit neater and tidier. Right, so now our UV solder mask has cured. It's now rock solid, and we've provided some extra insulation there. Next thing I'm going to do is solder on my jumper wire. Now I've got a fairly fat piece of wire here, but it should be fine. So I've already put a little bit of solder onto the end of the wire, and then I'm just going to apply heat to this pin here and to the wire, and I'm going to solder those together just like that. Okay, so we've got a nice tidy join there, and then we move across to this pin here, and we are going to grab the other end, and once again I am just going to get the end like this from there and just apply heat, and that is joined. Okay, so that is our little jumper wire that runs from there to there. Okay, so the next thing we need to do is focus on this part of the board here, down near the connector of the analog board. Okay, so our main focus at this stage is on pin 20, this one right here. Now what we're going to do is we're going to follow this up, and we can see that he runs along here, and then he gets to this little junction just here. You see J78, and right here you can see a resistor, but it's actually got 000 on it, which means that that is a 0 ohm resistor. So in other words, there's no resistance at all, and that is working as a jumper. So it's actually just connecting this to this. Now we need to remove that connection. So what I'm going to do is I'm going to use my hot air station, and I'm going to apply hot air to that, until that solder melts, and then I'm going to get this little resistor, and rather than remove him from the board, I'm just going to turn him sideways like that. Oop. Just like that. Alright, so what we've done now is we haven't removed any components. All we've done is just break that connection from there to there. So now that pin 20 here is isolated. It doesn't go anywhere. So the next thing we need to do is we need to isolate pin 25. So here's 20, here's 21, 22, 23, 24, 25. So that's pin 25 there. And what we need to do is we need to cut away here, and we need to cut away here. Now I'm afraid I am not too thrilled about using my Dremel here, because that is such a fine area. My great big cutting tool will probably make an absolute mess of it. So what I'm going to try and do instead is I'm going to try and cut this with my scalpel blade, cut through that copper to isolate that pin. Alright, so once again, perhaps not the prettiest job in the world, but I have managed to isolate pin 25 from the traces around it. So once again, I'm going to paint that in some UV solder mask just to protect those exposed areas of copper, and then we will go and create one more jumper. Okay, now for the very last stage of this modification, and that is we need to create a jumper between pins 20 and 24. So that's 20, 21, 22, 23, 24. So we need to create a jumper that goes from there across to there. Now for this, I'm going to just use a little piece of enameled wire like this, and I will just solder that end onto there, and then I'll just bend it around and solder it onto there. So I'll start off on this side. It will be easier to get one soldered down first. It will then make it a lot easier to manipulate that wire around to the other join. Okay, so just going to hold this here. Now this is enameled wire, which means it has a little coating on it, so we need to apply some heat to it in order to get that coating off. So as I apply heat here, that coating is coming off, and then I'm just going to add a little bit more solder to the join. A little bit more flux so that we neaten that up a bit. There we go. Okay, so there's that one, and then we just need to bend that down to there, and I do it like that. There. So once again, good dollop of flux on there. Get some solder onto the end of my soldering iron and just hold that in there and melt that enamel away. Gonna need to get some solder here. Okay. Just gonna. There we go. All right. Okay, so now I just need to trim off the excess wire here like this, and we have created a little join from pin 20 to pin 24. We can just confirm that quickly with the multimeter to make sure that we have got continuity between those 2 points, and we have indeed. So that's all fine. Okay, so I'm just going to paint that join with a little bit of UV solder mask to help to protect it, and then we'll test it out and see how it goes. So here's the Color Classic with the modified analog board installed. All that remains is to install the LC575 logic board. Now I have a recapped LC575 logic board here. I haven't gone into any details about recapping in this video, but if you look at my channel you'll find lots of videos on the subject. Alright, so let's spin it around and install the board. Okay. Now, one thing you might notice is that the ports on the back of the LC575 board are in a different position to the ports on the Color Classic. As a result of that, the cover for the Color Classic won't fit when you've got the LC575 board installed. One of the things you can do is to just leave the cover off, but if you prefer to have one there, you can jump onto eBay and actually purchase rear covers for the Mystic upgrade. Alternatively, if you have a 3D printer, you can actually print out your own. Right, so the next thing we need to do is to switch it on and test it. After completing the 640 by 480 modification, it may be necessary for you to alter the geometry of the display using the controls at the back of the analog board. So if we go up to about this Macintosh, you'll see that the computer is now identified as a Macintosh LC575. And we're now displaying at 640 by 480 pixels. The pixels are quite small on the screen, but still quite usable. I do hope you enjoyed this video, and thanks for watching.
As a test of your abilities, the king has appointed you as regent over a small parcel of land. Since we must keep our armies in the field well supplied, you are to build the town into a farming center of no less than 6 farms. Construction of a barracks for defense is also advised, as our scouts have reported orc patrols in the area.